Welcome to this video, Acid-Base Reactions. In this video, we'll view several video clips that demonstrate the use of an indicator to follow the neutralization reaction that occurs when we mix an acid and a base. We'll also go through several examples to apply what you've learned about acid-base reactions. An acid is a compound that dissolves in water to give hydrogen ions, H+. A solution of hydrogen chloride gas in water is called hydrochloric acid and is acidic because of the following reaction. An indicator is a compound that changes color depending on the acidity of a solution. In the movie below, a few drops of methyl orange are added to a solution of hydrochloric acid. This indicator turns red in acidic solutions. A base is a compound that dissolves in water to give hydroxide ions, OH negative. A solution of sodium hydroxide in water is basic. Acidity and basicity are linked because of the reaction shown below. In the movie below, a few drops of methyl orange are added to a solution of sodium hydroxide. This indicator turns yellow in basic solutions. Acidic and basic solutions. Which solution below is acidic? When the indicator methyl orange is added to the solution, it turns red, indicating that the solution is acidic. Strong versus weak acids. Strong acids are compounds that are completely ionized in solution. That is, all of the molecules that make up the acid break apart in aqueous solution to form ions. Weak acids are compounds that partially ionize. That is, a few of the molecules break apart into ions, while the majority of molecules do not break apart. This is a strong acid. Note, every molecule breaks up into ions. And this is a weak acid. Note, only a few molecules break up into ions. When strong bases dissolve in water, they release all their hydroxide ions into the solution. A weak base, such as ammonia, reacts partially with water to produce OH negative ions at a lower concentration than a strong base would, as seen in this formula below. The chart below lists the strong acids and strong bases. Neutralization reactions. When an acid and base are mixed, a reaction occurs to form water and a salt. For example, when sodium hydroxide solution is added to hydrochloric acid solution, this reaction happens. The hydrogen positive and OH negative ions combine to form a water molecule. This reaction shows the salt formation. Sodium chloride, the salt, is soluble in water. Since nothing precipitates out of the solution, in order to see a neutralization, it is necessary to add an indicator. In the movie below, a clear sodium hydroxide solution is added to a hydrochloric acid solution that contains a few drops of methyl orange indicator. When all the acid has reacted, the indicator will turn yellow, since the solution will then contain an excess of sodium hydroxide, a base. Reactions that generate gases. When acids are added to certain ionic compounds, a gas is formed. The movie below shows what happens when hydrochloric acid is added to a solution of sodium carbonate. The sodium and chloride ions remain in the solution. The H+ and CO3, 2 negative ions, combine to initially form carbonic acid, H2CO3. However, Carbonic acid is unstable and immediately decomposes to give carbon dioxide and water. The carbon dioxide is evolved as a gas, the bubbles in the movie. Let's work through 3 additional examples of anions that produce gases when acid is added. Anions that produce gases. When an acid is added to any carbonate, carbon dioxide is evolved and water and a salt are produced. Compounds that contain the sulfide or sulfite ions also produce gases when an acid is added. Even though the calcium carbonate is a solid, it will react with an acid. The ionic product, calcium chloride, dissolves in water. The H+ and CO3 2- ions combine to initially form carbonic acid, H2CO3. However, carbonic acid is unstable and immediately decomposes to give carbon dioxide and water. The carbon dioxide is evolved as a gas. In this case, the potassium and chloride ions remain in the solution. The H+ and S2- ions combine to form hydrogen sulfide, a gas. In this case, the iron and chloride ions remain in the solution. Finally, the H+ and SO3 2- ions combine to initially form sulfurous acid, H2SO3. However, sulfurous acid is unstable and immediately decomposes to give sulfur dioxide and water. The sulfur dioxide is evolved as a gas. Now you give it a try. Here are some helpful tips. Write down your answers as you work through each problem. Write your answers as formulas, for example H2O, instead of phrase labels, water. Do not balance the equation. And finally, the product order is not important. And remember, you can always pause this video for more time to think about your answers. For the following reactions, try to figure out the answer on your own, and then watch as we show the correct products in the box provided. Congratulations! You have completed the video, Acid-Base Reactions.